Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland. Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en met mij is...
Hallo Ronald.
Hallo Jan.
Ja, mijn stem is een beetje zwaar. Ik merk
Ik
wel...
hoor het. Je stem is heel zwaar.
Nee, het is dag 2, althans voor ons al de dag 3. En ja, het is geweldig. We spreken zoveel mensen. En ja, dus mijn stem heeft wat te lijden.
Ja, dus ik zou de introductie ook niet langer laten duren dan. Ik zou je uit je lijden verlossen. I will like to introduce Carlos Santana from Amazon. Welcome.
Thank you for having me here.
Yeah, Carlos, you're a senior cloud solutions architect at AWS. And can you please introduce yourself to our listeners?
Sure. Like you said, my name is Carlos Santana. I'm a senior solutions architect for AWS, and I focus on with the EKS service. So my role is a technical role that I work with customers and the service team. And in this case, it's the EKS service team on gathering requirements, working with them on scale. But usually I work with large enterprises in terms of multi-cluster fleet management and then the practice of GitOps. And that's what gets me into Argo CD as a contributor. So I'm the SIG lead for SIG scalability in Argo. Argo CD is the one that comes up a lot, but it's all Argo projects, Argo workflows, Argo rollouts. But Argo CD is kind of like the main one that a lot of customers ask help.
I'm most familiar with, yeah. Yeah. And how did you get started in the IT? What got you motivated?
Oh, IT, I guess I'm going to age myself, but I got into the data center. So I'm an electrical engineer. So I work started in a different cloud provider in the data center, working with rack servers. From that, I started doing software engineering deployments. And I've done many architect roles from doing mobile when the iPhone came out, and then cloud exploded. So I was in a different cloud provider. I created a serverless service using containers when Docker came out. So it was an open source project. So that got me into open source also with a project called OpenWhisk. That was for Apache Foundation before CNCF. So Apache Foundation is still a popular foundation. And then I got into Kubernetes through the Knative project. So I was a co-founder with other companies. We co-founded Knative. So I was a SIG committee, like one of the maintainers for that project for the longest time. And from that got me into the Kubernetes community, and I got involved into the upstream project. And from the upstream project, I got involved with, I think I did docs in Spanish. I help a little bit of docs in Spanish because I really want to help the Spanish community in terms of getting into IT. And that I got involved with.
Is the Spanish community big?
Yeah, and LATAM is very big, and including Portuguese in terms of Brazil. So I work with a lot of customers using Kubernetes in AWS. From Brazil, there's a lot of bank industry over there, but a lot of industries use Kubernetes. And in LATAM, like Mexico and Colombia and Guatemala, we have CNCF ambassadors in all those countries.
Nice.
Awesome.
Nice. Yeah. You have a talk here, explain how Kubernetes works with the GPU like I'm a 5.
Yes.
So now I'm going to imagine I'm 5, and could you please explain to me what your talk is about?
Well, I wanted to do a talk on explaining how Kubernetes works with GPUs and how you can use containers with GPUs. So and like I'm a 5, I tried to make it a novice track in terms of like understanding deeply in one place how the connection and the integration between the GPUs and Kubernetes is involved. And for people that get started, they get into the weeds of trying to do everything with Kubernetes without understanding that there's a Linux operating system, that there's a container D, there's a run C, there's a kubelet, there's things outside Kubernetes that need to work, and you have to get it working and understand before you put the abstraction layer of orchestrating pods. So the talk was kind of like an experiment that I did at home. I bought one of those Jetson NUC devices.
They're awesome.
Yeah. So I have a problem in my house. My spouse keep telling me to not get more cables and gadgets and things like that. So I have for the longest time, I always buy small devices like Raspberry Pi. Before that was Esperino. I don't know. You have heard of Esperino. Like JavaScript on a system chip. But again, I got a bunch of Raspberry 2s, 3s, 4. I got a Turing Pi. Turing Pi is very cool. It's one that you have a board with 4 sockets, and then you can install a Raspberry Pi module, not the complete module, or an NVIDIA module. In this case, one of the Jetson modules you can install there, or one of that comes with them like R1K1 that has an NPU, a neural processor unit. But I got a Jetson one because I wanted to play with NVIDIA stack. A lot of our customers in AWS work with NVIDIA. Also, we have our own processor accelerators chips, but NVIDIA is one that a lot of people have game PCs that they can get started. So
and the CUDA is really easy to use.
Yes. So CUDA is an NVIDIA library.
Yeah.
And most of the folks that get started with this, trying to do machine learning on AI at home, you use one of the popular projects like PyTorch, for example, or one of the recent ones like OLlama or llama.cpp. So I wanted to get started using those. And at least for me, it was difficult to find documentation in one place that explained the Kubernetes stack on Jetson. It was always like people trying to run containers or run Python code in Jetson on Linux, but no Kubernetes. And then I found some articles about Kubernetes, but they were very old articles. So I couldn't find something like that. So I also am a CNCF organizer for a community called the Kubernetes Book Club. So that's a community that I have other organizers helping me. So every week we discuss a book, or right now we discussing platform engineering for architects. So that's a 10-week one. But I did like two sessions on like how to do GPU or machine learning at home. From that episode, I did some live stream. I do live demos and. Nice. We together, like people on the group, like between all of us, we tried to figure out like how to get Kubernetes running on the Jetson with the right driver, the right CUDA, how the GPU plugin works. So the talk is around breaking down all these different parts on what the GPU plugin does, what is the upstream node feature discovery does, what's the GPU discovery does, like why do I need to label the nodes? How does GPUs get allocated on the pods, right? How do you share a GPU? What is the compatibility layer between the driver and the CUDA that you were mentioning? Like the CUDA and the driver, they need to go together in the certain versions. And a lot of users, believe it or not, waste a lot of time trying to figure out to install all these things in the cloud. So I'm going to go to the cloud example. So for example, in AWS, we give you AMI images, like OS images that have the correct driver and the correct CUDA and the correct container toolkit for Containerd. But folks find information online and they try to install for example, the operator, and then that would install a different version of the driver and then things stop working. Where I did the research, and most of the cloud providers already give you an OS that has almost everything. Some of them you need the GPU plugin. In AWS, we have an image called BottleRocket, which is the container OS, already comes with a GPU plugin. So you don't have to do anything on it. But the idea is sometimes people start with that, but we engineers, we want to know like what's behind it, because when it doesn't work, I want to know like how it works so I can troubleshoot it, right? That's the main reason. It's because you don't need it now, but you will need it when you're in a crunch of getting a project deadline, and you don't know why something is not working. And it could be something very simple, but because you don't understand the complete stack from bottom to the top, you may be something simple, like you may say RBAC for the node feature detection, right? Or it could be that the labels were not put correctly, or you misconfigure the Containerd runtime. You didn't put it as a default. So simple things, if you know understand how everything gets together. But
yeah.
if it's you go with do a Helm install and then like pray that all this YAML get in there and then everything works and boot up, then you get into trouble. Like that in our industry, like in this conference.
If you like to hurt yourself, do it that way.
Yes, you can do the Helm install. What I in my talk, what I told folks was, you as an IT admin of Kubernetes, you need to know deeply what that package has inside, because it has a lot of options. It has a lot of things like optional components that get installed, defaults that are like very permissive, because it's the balance between when somebody getting started and installing something in kind, right? You want to make it super easy for someone to use your package as an open source maintainer. Mm-hmm. You want that friction to be nothing, right?
But then it's not production ready.
It's not production ready. So where's the book? Where's the video? Where's the guidance? Where it would tell you like, this is how you do it to get started, and this is how you do it in production. And then the third one I would say that I encountered the most is, how do you make it scale and secure? Right? Because sometimes you have it in production running and it works, but then it doesn't scale. You start having problems on not scaling, and it's because resources not allocated correctly, or you don't have a dynamic allocation scaling associated with that component. And it's sometimes the open source project maintainers don't know what other components from a different project you bring in to integrate with your component to make a scale. So one example is KEDA, K-E-D-A. Mm-hmm. It's a very popular one to scale, but you don't see that often on other open source projects saying you can use KEDA with our project when you need to scale it, right? Because they just focus. They don't have a lot of maintainers, right, to look up every integration possible. But on the field, when you work with customers, right, integration is kind of the most of the time that's spent on doing, because you're trying to put these Lego blocks together that meet the requirements, meet the regulation requirements, and the scaling requirements.
Yeah. So how far is Kubernetes at this moment using the GPU and even the CUDA cores? Because I know that the scheduler of Kubernetes was not built with the GPUs in mind for AI workloads specifically. So you could run a container and you could assign the GPU or a node. You could assign or label it with it has a GPU. But how do you distribute the GPU workloads equally over the containers? You know, when you run an AI job, or I run an AI job, need more resources from the GPU at a certain time than you. How is Kubernetes solving that problem at the moment? I know in the past that was a thing.
So right now, the way that there's a new projects coming up like DRA, but the basic ones are coming from devices, and there's upstream support for that. Related also to my talk is the way it works is, for example, don't take an example like GPU. It works very generic to any device. That's why you see in upstream Kubernetes saying device. You never see GPU, but people are looking for the searching in the search box, right? They put GPU and they cannot find it. It's device. So imagine if you have a server connected with 5 printers, USB printers, and you have containers that they want to print.
I get a chill over my back right now. 5 printers on the server.
Right? So it's the same thing, right? So you can have one printer on that computer, right, connected to the cable. It's the same thing as having one GPU connected, so that needs to be shared. And then you can have 2, and they can also be shared. So the idea is like their GPUs are very scarce. I guess the same as printers. You can print it anywhere when you need one. It's kind of the same as the GPUs. But the Kubernetes works in the way of like allocating devices. So the GPU plugin will work with the kubelet through a gRPC, telling the kubelet, these are the number of devices that I have available. So if you have one GPU, the kubelet set would put the allocations on the API server saying this node has one GPU available. So when the pod requests one GPU, that pod will get assigned there, and then the kubelet will like decrease like the number that are available. We'll ask the GPU plugin to ask like, give me a GPU, and it's not available. So in terms of scheduling, is the same basics that for the last many years I've done in Kubernetes, because you don't want to create something new that suddenly everybody needs to upgrade to the latest version of Kubernetes, because on real life, people are still running 1.24, 1.25. We're trying to make it super easy to upgrade.
Also on the AWS?
Sorry?
Also on AWS, are you supporting those old versions?
Yeah, we added last year. We added extended support. So for a fee, you can get extended support, and we'll work with the patches and everything in upstream to get those things supported. 124, I'm guessing, is the last one that we drop support, and then like 125, 126, we drop it. We are like up to 132. But we have extended support.
Okay.
Yeah, beyond the normal 14, the one that upstream Kubernetes gives you.
Yeah.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
But still, when you have like a node with a GPU, let's say one GPU, and you want to distribute the resources of those GPU over the pods that are likely have like 4 pods, how can you distribute like 25% to each pod?
So the Alexa in the NVIDIA one, if you want to share one GPU, because the use case is if there's a pod that lands in that node, and let's say that pod is not using it during a certain amount of time, you're wasting another pod can use it, right? So NVIDIA supports 3 modes of sharing, like time slicing, MPS, and MIG. So the most general, the first one that you start with, like more simple one, is the time slicing, which is like you tell the GPU plugin, like, you have one GPU, a real physical one GPU, but I want to time slice it into 4. So it tells the kubelet, I have 4 slots, right? So 4 containers can land in there, and then the CUDA driver will figure out how to share that. The thing is, if one of them crashes, the other 3 containers, right, there's no isolation, in memory will crash. So you have that risk. But for the most part, in certain use cases, it works out of the box. The other one is MPS, where you have another agent or controller running a daemon set, and it comes with that Helm chart device plugin. And that will coordinate who has access when. So like you mentioned, like, well, this pod is in, the other ones can't, and it will start like giving time slots into it, kind of like the same as the CPU 100 millisecond time share. And the last one is MIG, which is a feature on the hardware that will do kind of like hardware virtualization. And that's not like, for example, the GPU that I have at home with the Jetson doesn't support MPS or MIG, but the high-end ones support hardware virtualization. And then we'll give you a hard isolation. Then the GPU plugin will say, I have 4 virtual GPUs, and then the kubelet just goes to the API server saying, I guess you have 4. And the schedule is the same thing as the Kubernetes upstream scheduler, like working with the kubelet, working with how many have available in the status. And then as things and as pods are running in that node, the number decreases. But it's a orchestration between those things. Very difficult to understand. Like if you're listening and you're new to this space, it's very difficult to understand. I'm trying to make it like sound that is super simple. Like, why would you not understand this? This is super complex for people that are getting started on working with AI chips, right? Not Kubernetes. I have 8 years or more experience on Kubernetes, almost 8 years. And it was difficult to me to figure out, like, oh my God, I know Kubernetes, but I cannot get this working.
Because we had NVIDIA on, and I know they had a collaboration, or they fused with the Run AI. I don't know if you heard about it.
Yeah, Run AI.
Yeah, and they had a custom scheduler that managed certain things we are talking about. So that's why we are a little bit familiar with. That's why I asked the question: how do you
Run AI is acquired by NVIDIA?
Yeah, it's acquired by NVIDIA.
I met the folks here, but that's at least my talk only have 25 minutes, right? I wanted to discuss someone that understands that basics now can go to the higher level schedulers, right? When you have like a custom Kubernetes scheduler saying, I'm going to land this pod in that node because it's more efficient, because maybe the data is already cached in that node versus this other node that is not over here. Or that this type of workloads are not optimized for the different type of chips, right? There's different versions of NVIDIA.
Yeah.
Also, AWS have different. We have Trainium for training and inference chips. So maybe you have a combination of nodes. You have some that are GPUs, some of that are like AWS chips, and some of them that don't have any accelerator, right, for your front end apps, web apps. But at the end of the day, the kubelet has an API, which is a plugin. And then there's a newer one that is coming up called CDI. I didn't include that in my talk because I think the one that explains the one that like is stable, is there. This is the one that started. Mm-hmm. But if you understand that one, then you can store CDI. That containerd has a new way of like dealing with devices.
But you don't also, like you said, you only have 5 minutes, and now we have like a half an hour, so we can a little bit widen the scope a little bit.
And CDI, the kubelet does done something with devices. What's the
So the kubelet, the role of the kubelet, it doesn't interact with any devices. Basically, it has a.
Oh, you said containerd is then interacting with devices.
Yeah. Containerd, because like the vendor would provide a shim on top of runc. Mm-hmm. So it is in charge of like integrating into runc the hooks and the devices that it want to associate to that container. So the way, and I went a little bit in my talk on that of like. When you put the vendor, I call it shim or toolkit in containerd, basically you're wrapping runc to give you a chance to create a container but not start it yet, and then using the hook from containerd, and then that hook is a vendor specific to say, I'm going to insert. It could be a GPU, it could be a printer, it could be a health a device from a like health and monitor type of thing, and insert that into that container. And then start the container when everything is set up. So the containerd and kubelet are like open source projects that don't have to be aware of any specific vendor device, right? Or the way to talk to the driver or CUDA.
That's awesome.
It's a interface. We work with interfaces. So they have worked a while for making the CDI kind of the next level of like polishing those APIs. But people are running production today. So what do you do with people that have in production? So that's the kind of also the dilemma, right, of open source. As you innovate with new APIs, you have to maintain the old ones for a while, mm-hmm. deprecate them, and then eventually people will move to the new one. Like, for example, PSP. How long PSP was around until finally in the upstream Kubernetes we were able to remove that and then move to PSA APIs, for example. That's kind of like the big last one that we removed in upstream Kubernetes, I believe, right?
Yeah.
Nice. So what would your advice be if someone wants to get started? Let's say I'm coming from high school and I want to get started in the Kubernetes landscape and then and I'm interested in AI. What is the roads to follow in your perspective?
Kubernetes and AI will be like, you can do AI without Kubernetes, right? I think there's a lot of knowledge that you can gain from.
You can do that? No.
Yes. You can do AI. You can do actually programming without Kubernetes.
Oh, no.
That sounds so old-fashioned.
Yeah. But I think AI is, I don't know how to explain it, but if you're like, for me, programming was kind of like that niche of like, oh my God, I can like put keys in the keyboard and can make loops. I can like write a web page and then have everything. So I think that's the spark of like the people coming out of high school. AI will be something that they will be excited about. Like, oh my God, I can do things with AI. Like we were excited back in the days. I can do things with programming languages like Python and Ruby and PHP. So I think people in high school, it should be excited about AI and the things that they can do with AI. And IT. In terms of Kubernetes, that's say the same aspect at the level as Linux. For example, like why would someone in high school learn Linux and be an expert in Linux? That would be the concept today. Like be an expert in Kubernetes, because I think as Linux is becoming a standard everywhere, Kubernetes will become a standard everywhere. Like it will be everywhere like HTTP. Like we don't question if HTTP is a good thing or not. It works. It's there. That leverage it.
But still, do you think somebody, you said it already, first needs to learn Linux and then Kubernetes and then AI?
I think they can start with AI, because AI is the thing that will help them learn. I'm learning new things today. I'm using AI for my own learning, right?
Yeah, but that's asking things to AI, but installing AI or using AI in your application.
Yeah, what you mean? You want to know what's under the hood, right?
Yeah.
How it works.
Well, do you want to know how the transformer coding works to be able to be efficient at your job? Right? I will question that, right? Not everyone needs to read the paper of the transformer to understand how LLMs work under the hood to be able to have an application scale to a 5,000 worker node container with observability, and I build a platform to do DevOps, right?
Yeah.
So it's which abstraction layer do you want to be at, right? There are people that are in school, like I said, like people in high school that are going to computer science to learn about data science. Mm-hmm. So those folks should be able to figure out like what would be the next layer of you get models more efficient, work better, those type of things. Then there's other folks that are like more networking, operating system, debugging, TCP, networking, that are the IT folks that are going to get those models working efficiently, right, and cost effective. So it depends what is your passion, right? But to run AI on Kubernetes, it will be the thing that you'll be encountering as you enter the workforce.
Yeah.
Like,
but what you also said is like when you were in high school, nowadays or in the past, you learned like PHP, Python, Ruby, and Rust maybe now. If you like learning AI, it's more like universal, right? It's not like you're learning all the different, and you can pick the one you like. Okay? You have like a preference for Go or for Rust. But if you do learn AI, how do you differentiate the AI itself from I like, or do you think it's more like I like Copilot more than I like ChatGPT or Grok, for instance? That's also a question. That's what popped up in my mind. So
yeah,
you can getting it more like universal knowledge instead of broadening it like in different ways.
Yeah, exactly. So AI is an utility that makes you productive, right? Either you're writing or programming. So it depends where you look at the perspective. Are you like an IT person trying to provide a service that is providing AI services, right? Or you are a person that is consuming AI service to make you productive in what you do daily, right? It could be writing a paper, writing a presentation, writing programming, but it's not like choosing this AI 2 versus AI 3, right? It's something that makes you productive, and there's different aspects to it. And I think in this conference, most of the people in this conference are the ones like, how do I run AI workloads efficiently, right? The same way we were 3 years ago or 4 years ago, we were in the same KubeCon saying, how do I run microservices efficiently? How do I make them communicate securely? How do I make efficiently, meaning like it could be for performance or it could be cost optimization. In this case, AI uses accelerator chips, right? And they're very costly or very like difficult to find if you're on premise to get servers right at home. Yeah. But how do you maximize the usage? And that's why the question that you asked at the beginning, like how do I make 5 pods share a GPU like efficiently? Is the same question we were asking before. How do we make 5 pods share a CPU, right?
Yeah.
And the memory, so it's a constrained amount of resources on a worker node.
Yeah, because also in my mind, I was using like AI for like scripting and stuff, and it always started off with Python to use for the things I wanted. And I don't know if the AI has a preference for Python, and maybe
I think it's related to the humans that were like working in that space. Python is very popular for machine learning, data, pandas, like all these libraries that are in Python, easy to get started. But I think at the beginning I saw that, but lately it supports many things. And one example I can give you was for one of the projects I'm doing with Argo. I have a project called the Giros Bridge, using Helm charts. I had Amazon Q is a free chatbot that we have in AWS that you can use VS Code, but now we have a new one that is a CLI one. So you can do Q chat, and it has access to write files, read files, and execute commands. So I told it like I needed to create a new Helm chart from scratch, put it in this folder, and I wanted you to create a Helm chart that creates vClusters with labels and all the possible labels around cloud providers. And then the thing just did Helm charts, it go templating, and I told it like, oh, go ahead and test it. You have access to my EKS cluster, use kubectl, and you have Helm, and it executed the thing. It found errors, and it was like I told it like to check conditions on various. YAML said like, yeah, check that I can use this Boolean, and it created 2 namespaces. It deployed to the 2 namespaces and compared the results. You kubectl get pods, get logs, created a little program to test it. Everything in my CLI. Every time it was going to execute something, it asked me if I wanted to execute it. I said yes. It also has the option to say accept all, where I will not run it in my laptop. I will run it inside a container. Right? But I did the experiment myself. I'm doing the experiments myself, and it blew my mind. Like it went and did, because I don't know every Go template supported in Helm, right? And the for loops and the if statements and then all these options, and it got me 90% there. It wrote me the README, right, for the repo, and I just put it in GitHub, right?
Nice.
It was Amazon Q, and I put a statement there saying like, this thing was mostly done by an AI agent helping me, right?
It's like the comment above the scripting, right? And it's, you just write your name and when it's done.
And it's not for people to be scared, or is I want to be transparent, right? I didn't do it like this, or maybe excite someone say like, oh, I didn't know I could have a CLI utility that would like look through my files, or like create me a README, or create me a diagram, a dry IO diagram out of like my code, or go through all the Go code in a controller, right? And explain me like maybe write tests.
But the biggest thing, and what we face with our engineers, is that they use AI, but they have to anonymize first everything before they put it in AI, because our policy is not to do customer data.
Yep, exactly.
And so that's still a big hassle. And we are looking, and we are a small company, to run our own AI on premise. You don't know that yet, but I'm busy on that.
It's not a weird thing to think about as a company.
Yeah, on premise or on the cloud, I have a lot of end users using AI on their EKS clusters, right? We have SaaS services that give you an AI API like Bedrock, but we also have customers like, I want to train my model with MFlow, right? Or Array, which is our framework for AI and data. And they run on EKS, like, because maybe one of the reasons that you said, like they want to have all the data transfer inside the Kubernetes cluster.
We're still a bit scared that AI trains on our customer data, and the customer data returns somewhere in the question of my
competitor.
Yeah.
You should be able to download the models, right? Like libraries.
You can have air gap.
Source. Like you can
everything
take the Azure one, you take the AWS one, the GCP one, and just use them locally.
And you can go to Hugging Face.
But the thing for that is a concern that is valid. But there's practices out there. There's a term or practice called guards for AI. In Amazon Bedrock, we have that implementation of like doing guards for like maybe words that you don't want to be said, right? Or sanitize the data in, sanitize the data out. That's a SaaS service. But I want to say that that's a practice. We offer that in our service, but that's a common practice. If you go online and talk to the folks doing AI and model, like LangChain, for example, has a hook for that. Like there's a lot of libraries that have like already the guards aspect on it. So it's okay to be scared, but people are coming up with good solutions, right?
Yeah.
Cool.
Okay. So
I've got still another question.
Okay.
What is the biggest mistake people make if they use GPUs in their cluster?
The biggest mistake, if they use GPU in their cluster, is leave them running while not using them, and it costs a lot of money, right? So one of the things that we advocate is for auto scaling, like something like Carpenter, which is supported on AWS and other cloud providers. Carpenter will scale down those nodes if they're not used, right? And scale them up on demand. So I think that's the biggest mistake, is the one that hurts the most, is not doing cost optimization, right? For those, because GPUs are scarce resource and you want to maximize the usage. So you can say pods are not landing, but the node's still running, and you pay for the node. Like, you can scale it down, and things like Carpenter can do beam packing easily, or just remove the node if nobody's using it, and it has policies. So Carpenter is for those that don't know, it's an open source project, and the node SIG upstream, and then cloud providers have their downstream implementations of it.
Okay.
Yeah,
Nice.
Carpenter is great, by the way. It's just a little remark. Go.
Yeah. Oh, thanks. Oh, well, you alluded it a little bit in a few minutes back, but our final question is always, how would you like to see the future of Kubernetes?
So the future of Kubernetes, I think, is getting close in one aspect that, at least for myself, that I'm very passionate about. When I was working in the Knative project, we were building an abstraction of taking a deployment, an ingress, and a configuration all into one CRD. And this was when I think we did it about the time that CRDs came out. So before CRDs, we were creating controllers, but we created a CRD for Knative called service, and we put those three things together: a config map, the traffic shifting, and a deployment. Right, those three things, like normal things that you put a Helm chart and deploy, we created a CRD, but it only worked for that use case. The future of Kubernetes, at least I'm working on a project with all the cloud providers, AWS, Microsoft, and Azure, are working on a project called CRO, Kubernetes Resource Orchestrator. So we are looking into putting this project into upstream Kubernetes to be an abstraction layer that you can create CRDs with any type of Kubernetes resource. So, for example, putting an ingress, a service, and a deployment, and calling it my app. And basically, in my app, you can put like, what is the image that you want, and deploy it, and then the CRO controller would orchestrate those three components. And it's very lightweight, and using the CEL common expression language is the one that we use in upstream validation policies. But the reason that the cloud providers are coming together in this project is because people are like configuring cloud resources using Kubernetes. So the future of Kubernetes, I think, is going to look more of an abstraction layer also for the cloud provider APIs. So you can put together, for example, in AWS, we have a project called ACK, Amazon Controllers for Kubernetes, that you can create from a VPC through a subnet, through a Kubernetes cluster, to an S3 bucket. But those need to be wired together.
Yeah.
And also, if you're going to use it from an application, you need the deployment. So the CRO project basically is a way that you can create your CRD on the fly with CEL to put these things together, and then create your CRD called my app. And you can do it in another cloud provider and the next cloud provider. So I think a lot of folks will see in the Kubernetes space getting more knowledge about CRO, and it's a project just getting started, and we're asking for input is in the Kubernetes Slack. So we're trying to put that in the upstream Kubernetes, not being a CNCF project, but it's upstream Kubernetes. Like the thing that I wanted to do in Knative, kind of create a deployment V2. And I think SIG apps had something like that also. So there have been different attempts on that abstraction.
Removes that the need for Terraform?
You can still use Terraform. So it's for the cloud providers, at least in AWS, we have people using CloudFormation, Pulumi, Terraform. So these are for folks that want to use Kubernetes, right? That people are like, I don't know what Terraform is. I know what kubectl is, right? Right?
Okay.
So I want to create a S3 bucket for my app that is running on my pod. How do I do that simply?
So
right?
I would create an S3 bucket on a CRD, and it creates an S3 bucket in AWS.
Yes.
I think that's awesome. And that simplifies also my application deployment.
Yep.
Because now I have to deploy my application, do some Terraform or Plumi or
Yeah, CloudFormation.
CloudFormation
There's many projects. Yeah,
and to provision an S3 bucket
Yep.
beside my
YAML, a little
application.
YAML snippet that you put all the information in there and gives you an S3 bucket
How
for
does
your
the story
application.
of yesterday relate to this? Maybe the inheritance of the CRDs. Is that something that to look at in this context, or?
Yeah. not going to that. But this, I would like to have that.
Yeah, I've done many. We can talk this week on that. You can go through the AWS booth or the other cloud providers and ask about CRO. So the putting ACK. So it's for cloud, like but I mentioned, you can put a deployment, config map. People are saying it's a Helm replacement. I would not go that far. If it were me, I want to see like how the Helm community can work with CRO, or maybe it's a Helm V5. I don't know. Maybe it's a Helm inside the cluster. But we have folks from the different cloud providers and people that were like back in, like when I was back in the days in Knative, coming together, like what is the proper thing that we want to do in API upstream that maybe we did it wrong in the past, right? Like doc typing is one of the practices of like doing doc typing in Kubernetes, because in Go it's like everything is very strict, but there's aspect of that you can do doc typing and the versioning of that CRD, and how do you roll out your changes on your CRD in a way that is promotion based, right? You don't want to change the abstraction on all clusters and all APIs. You have thousands of people using this abstraction. How do you roll it out? So those are the things that we're like trying to figure out with the community, instead of like building something and then put it into the community. So that's why we gave early access between the cloud providers to come up with that abstraction of like, how do I do the chicken and the egg kind of thing, right? Sometimes you want to create a cluster, but you don't have one.
Yeah.
Yeah.
No, I think it's awesome.
I hear a follow-up episode in the future.
I'm happy to come here and talk about CRO and what we're doing in that project. So we have demos in the booth if people want to check it out this week.
Okay. Well, Carlos, thank you so much for joining us
it was
and
awesome.
sharing your insights. Everything that's happening in the GPUs, AI, and the CRO in this instance. So, what I said, I'd like to follow up this conversation in the near future, and so I hope to see you again.
Yeah, thank you for having me.
Okay,
Thank you very much.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl, via Spotify, Apple en alle andere favoriete podcastproviders.